Hi. So there's this DevC challenge that I want to try. So the challenge is, how do you find the middle element of a singly linked list in one pass? For example, given a linked list, the middle element in this linked list is 8. So this is the linked list. So out of this, I think the question that I had was sorry, the question that I had was, will the linked list always have an odd number of elements, or do we expect both odd and even number of elements? And if we expect even number of elements, which one should we consider as the middle element? The last element in the lower half, or the first element in the upper half of the even list? So in this case, I'll make an assumption that the number of elements will always be odd. Yeah, so let's get started. So first of all, a singly linked list is a linked list in which one node points to the next node, and the next node points to the next one, until we reach a point whereby the last node points to a null. Ideally, that's how we know that we are in the last node. So the approach that I think would be optimal is to recursively go through the elements in the list while keeping track of the count, and then knowing where each node lies using the count. And then when we get to the end, we will know the total number of nodes. And then while we are on the back pass of the recursive calls, we will be checking whether we are at the midpoint, or the middle node, and yeah, return that value. So to begin, let us first define our node. We'll use Python in this case. So let's just say class node, and then class node, we will define the init function. And the init function will take a value, the value of the node, and then we will also need to define and also the pointer to the next node, and this one will initialize it to none. Then over here we will say self.value, we give it value, then dot next is equals to next. So right here, this is how our node will look like. And then, because it's a linked list, we'll also need to define the class of the linked list. So we'll come here and say class linked list. Oh, sorry, linked list. And then for the linked list, we know that it always has the start node, which can point to none, which will tell us that the linked list is empty. So in this method, oh yeah, in this class we will initialize it with self dot start node, start underscore node, we'll give it a none. We'll give it a none, and then we will need a way of inserting a new, or rather, yeah, inserting a new node into this list. So for this, we will go ahead and define a function and a method, and we will call it insert. So we can say that we're inserting at the beginning of the list or at the end. So in this case, we'll just go to insert at the end. So insert at end, and then we will take value as a parameter, yep. And then what we want to do is say that new node is equals to, we instantiate a new node, and then we pass in the value that will be held on that node. And then the first thing that we want to check is if the linked list is empty. If it's empty, then we know this is the first node. So what we say is if self dot start node is none, then automatically we know that the linked list is empty. And then what we want to say is self dot start node, we give it the new node that we have just created, and then we return. But in the event that the list is not empty, then we want to insert the new node at the end. And how we'll do this, we'll need to iterate through the list, or rather walk through the list up to the end node, and then that's where we assign or replace the new node. So for this, what we will do is we'll say, first of all, we'll say node is equals to self dot start node, and then we want to say while node dot next, node dot next is not none. So we always want to sort of, yeah, so we're walking through. So in this area now we say node is equals to node dot next. So this will walk us up to the last node, whereby we will hit the condition whereby node dot next is equals to none. And then what we want to do is just say node dot next now is equals to new node. So that will enable us to insert a new element into the list. Okay, now that we have this, time to implement our recursive function that will enable us to sort of walk through the linked list and get the middle element. So this is what we will do. We will define a new function, and I think we'll call it navigate list. So def navigate list, and then this function will take in a node. So we assume that we'll pass it the first node in the list, and then it will take care of the rest. So it will take a node, and then count, which we will initialize to 0, pass it as the default parameter, and then at this point we want to say, because we are already at that specific node, we want to say count. We want to increment the count by 1, and then we want to say current node, I'll say position. We'll assign it a count. So the reason as to why we assign it is because we will need this value to check whether we are at the midpoint or not, because the value of count will always be changing, so we can't use it, and we want each node to have a unique count. So after we do that, now we want to check first of all I will call it the exit condition, or rather, okay, we can go ahead and say if node dot next is not none. So this is like telling us we are not yet at the end of the list. Is not none. What we want to do is get two things. We want to know whether we are going forward or backwards. So if we are going forward, then we need something to check. So I'll write, we want to get the total, and then I will introduce here a variable called found, and then say this one will be equal to navigate list, and then we want to pass in the next node and the value of count. And the value of count. So what we'll be returning from this function will be the total number of elements and whether we are going forward. So if we're going forward, will be the value of found will be true, no, false. And if we are going backward, the value of no, we want to know whether, okay, I'll explain it after I've written it. So at this point we want to say if found. This means that we already know the midpoint. So if found, we just want to return the total and found. Then here is now where I think it will make more sense. Now over here we check. we want to check if the current node position is equal to, remember at this point we already have the total number of elements in the list, so we need to just check if it's equal to halfway this. So how do we get the half point number? So for this I'll define a method quickly over here and call it get middle number. Def get mid number, and then this one will just take a number, and what this one does, I'll import math, and what we want to return is simply return math dot ceiling of number divide by 2. So this will always give us the middle number. Okay, so at this point we want to say if it's equals to get mid number, and then we pass in total. So if sorry, okay, so what's happening over here is if this condition evaluates to true, we'll know that the current position is the middle number. So what we want to do instead over here, we want to say return node dot value. So this is now the value of the current node, and then we want to also return true, meaning that we have already found the node. And remember over here we are checking if found is true, then we don't do anything, we just propagate the value of total and found. And remember here now the value of total will not be the total number of elements, but rather the middle value of the middle element, the value of the middle element. Okay, and then we want to say if that did not evaluate true, we want to return the total number that was returned. So the same as here. So we want to say return total and found. Then at this particular point, this will enable us to know whether we found the total or not, and then return the same. Then eventually in this now the function what will be returning if this condition is not met. So we want to return the count, and then of course false. So this recursive function will enable us to step through the entire list, and the time complexity of this will be O of n, because we will go through each of the elements in the list. So in order for us to get this into play, I think we need first of all to create that list, and for this I'll add another function. Let me pull this one down here. I'll create a function and just call it def create linked list, and this function will take in a normal Python list. So something like 1 2 3 4 5 6, and then from this will give us a linked list that 1 is the first node, 2 is the second node, 3 is the third node. And for this we'll say linked list is equal to linked list. So we initialize a linked list over there, and then what we want to do is create the first list, the first node. So we'll say linked list or linked list dot start node is equals to node, and then the value of the first element of the list that we passed in, it is that element, and then we want to iterate and create the rest of the list. So for this I think I'll just use a list comprehension, whereby we'll say linked list dot insert at end x for x in a range, and then we want, because we're beginning from the second element, which is at index 1, so this is list x, and then we want up to the size of the list, so we say len list. Yep, I think this will do, and then we want to return the linked list. How much time? Wow, 22 minutes. Damn, it's too long. Okay, so we know what this will do. So now let's get to it. Okay, one more function, def get middle node, and then linked list, and then what we'll say here is mid node, and then it's equals to navigate list. Remember, navigate list will return a boolean and the value of the element in the middle. And then I want to say linked list dot start node. This we made the bad assumption that the list is not empty. Anyway, linked list. Okay, and then we want to say return mid node. I think now we can get to now write our main in quote, or rather run this code. So at this point, what we will do, we will say list is equals to, and I think I'll just use these numbers that are here. So I think those numbers were 15, 9, 8, 5, and 6. So that's the list that we want, and then we want to say linked list is equals to create linked list, and then we pass in the list, and then from here we want to get the mid node, And then for that we say get middle node, and then we pass in the linked list, and then finally we want to print mid node. Okie dokie. Okay, so I guess at this point we are I guess at this point we are done. Let us run this code. Python. Yep, the output is 8, I think, as expected. So that is my solution, and I'm out.